my name is Nurul Shakirah binti Muhammad Arif. So this is my metric number. Here.
I am Fatima Nazira and this is my metric number. Hua!
Hi, my name is Yumiza Shahira. This is my metric number. Wait, what is that? That's clear. Okay, good. Up! Hey! Yo!
Are you guys ready? So, this is the objective of our project. First, to determine if magnets, battery and a copper wire are capable of creating a high source of magnetic field resulting in constant motion, making it the world's simplest electric train. Second, to determine the relationship between the magnetic field and the speed of an electric train. There are three variables here, which is manipulated is number of magnets, responding is the speed of train, and constant the length of coils.
Materials. First, a AAA battery, neodymium magnets, and lastly, a copper wire. Procedure. Firstly, put magnets on each side of the battery. Then, insert train into the copper wire and watch it travel through the wire.
Ever since the first time you opened up my world, I just can't seem to close my eyes and sleep. I'm locked inside this daydream.
Now, repeat the experiment using 4 neodymium magnets. Repeat the experiment again using 2 neodymium magnets. That's all. As simple as ABC, right?
For the concepts, the neodymium magnets on the ends of the battery create a bar magnet with a north pole and a south pole. When we put the train inside the coils, it causes an electrical current to flow through the copper wire, which creates a magnetic field in the section of wire coils right around the train car. This magnetic field has its own north and south poles, which push the train along the track. We notice that the train only runs one direction because of its magnetic poles. When the strength of the magnetic field increases, the speed of the train increases. When the number of the magnet used increases, the speed of the train increases.
Next, we move to our data analysis. Based on the data that we obtained from our project, we noticed that the increasing number of magnets will also increase the speed of train. This is because as the number of magnets increases, the stronger the magnetic field will be. We also consider some errors that can occur during the project and some precautions to it. First, if we wind the coil loops too far apart, the train running slow. Thus, we need to wind the track coils tightly. Next, the train does not work even with magnets placed on it. To overcome this problem, the magnets need to be placed on the battery with the poles facing opposite direction. To conclude, we learned that a battery, neodymium magnets, and a copper wire are capable of creating the world's simplest train. Adding more magnets to the battery, the more winding the wire into a coil, the stronger the magnetic field produced and the higher the induced energy, resulting in greater speed.